This is Lab 5, Choose Your Own Adventure, Drag Force. For this lab, I chose to analyze the motion of two different falling objects. One was a soccer ball and the other was an inflated latex balloon. Using Newton's second law as seen here, I was able to analyze and predict the motion of the objects and see the effect of the drag force. I found in my results that when drag was applied to the object, or the drag force was included, that the object fell a much shorter distance. You can see my results here as the blue dots are the experimental positions, the yellow is the model without drag, and the red is the model with drag. You can see that one of my models did a good job of predicting the motion and the other one not so good, and I will go into detail on this later. So first I imported my video into Tracker and I tracked all the data points as they moved, and you can see that the ball and balloon were dropped from basically the same height, and the ball fell a much further distance and the balloon fell a tiny bit. That was actually really difficult to track because the changes were so small. And I collected data over here, position data, and I later used that in the graphs, which I will go back to in a minute. Looking at my code here, you can see where I created the model, and this particular one is for the ball without drag. So I created a model for ball with drag, ball without drag, balloon with drag, and balloon without drag. And basically the main differences were the mass of the object, the starting position of the object, and let's see, the B value. That is my coefficient of friction, which plays a significant role in this project. And so coming down to my loop, or before my loop, I have right here where I was saving the position data over time at each interval into a spreadsheet that I would later use to put in my graph. And down here in my loop, I have it run from 0 to 0.44 seconds, as that's the length of the video. I have my force, I have my friction force, I have my FNAT total, which is the weight force plus friction force. I update the ball's velocity at each interval, I update the position, update the time. These are all things to create the image that appears, which I'll show in a second. And let me get. So here is the picture snapshot I took of the ball with drag model. The large arrow going down is the force of gravity, which is pulling the ball down. The blue arrow going up represents the friction force in the opposite direction of gravity, thus slowing the ball down. Here I have, I know it's really tiny. This is my balloon with drag model. And it's so tiny, and I couldn't figure out how to change the scale to make it bigger, but it's so tiny because the displacement of the balloon was so small relative to everything else. So the tiny green dot right there is the location of the balloon, the yellow dot is the origin, and the forces are so small that they really don't even show up in this model. Now looking at my results for the motion of the balloon, like I mentioned earlier, the blue dots represented here are the experimental data, and the red line is the model with drag, and that did a really good job of representing my the motion of the balloon. So except a little bit here in the middle, and that's likely due to my coefficient of friction being slightly off, even though I had it down to the, I think, 10,000th place. Here the yellow line is the model without drag, and I did this to represent the huge impact that drag had on the distance that the balloon fell. And over here we have the motion of the ball in the y direction, and similar case with the labeling and such. Now there came a problem with my experimental and model data. I believe that looking back, I'm pretty sure that I have left out my coefficient of friction is slightly off, and so that kind of skewed my values. Also, my frame rate, I had to deal with that, and that was a major pain for me. And I got it worked out for my other model, and I didn't do that for this one. So ultimately, using Newton's second law I was able to track the motion of the objects as they moved, as the different forces acted on them, which included the gravitational force and the force of friction, which was a function of mass. So the ball was not nearly as affected by the friction, even though it had a larger frictional constant, because it had a much larger mass than the balloon. So the balloon, despite its small frictional coefficient, it had such a small mass that that small frictional force had a huge impact on its motion. And that is my lab. Thanks for watching.